My job involves going out to different companies and helping them with their APT engagements, finding commodity malware, reversing APT, commodity, and all that sort of happy stuff. And then, and then on top of that, making security recommendations and helping them fix their APT problem. Today I'm going to be talking about doing mass triage. So one of the scenarios that we typically face in the RSA team when we go out to somebody's company is they have a huge network. You know, it's not uncommon to see 5,000 to 30,000 machines on the network. And this, a particular company gets notified by the FBI saying they have a potential APT. And, how do you handle, 300 or 30,000 machines and finding the APT actors? I mean, when you get the notice from the FBI, you maybe get one IP address if you're lucky. Maybe it goes to your proxy and then you're searching logs and things of that nature. So it becomes a real search inside the network to figure out where the actors have been. The other thing on top of that is even if you do get lucky and find one of the machines, you then have all the other machines that you have to take a look for. You have to identify those machines that the actors touch and at least see if there's any tools there, any exfil, and put a label on them to be re-imaged or whatever the proper procedures for that particular company is. All in all, it sounds like a big job, but it's not too bad. So what we look at triage is basically we're looking at doing a quick analysis to figure out which machines require a deeper analysis. We want to lightly touch every single machine. We want to have a small footprint because, we don't want to disturb evidence on the box. We want to keep it low key for our activities. So typically this is a management thing where they don't want it getting out that they may have been breached. So they don't even want the employees to know, so it's usually a core set of people. So we have to have tools that techniques that keep it low key. The other thing is triage shouldn't shut down the business. So we want them to be able to keep doing their everyday activities. That's going to be the same goals that your management's going to have, is to keep producing whatever product you produce. And in some situations, depending on what is found, it may shut down part of the business. So if it's a web company and we have to take the web server offline because of what's found, that's where those situations come into effect. But the biggest thing what we're trying to do with the triage is have big gains with little effort. One of the aspects of triage is, and you'll find this with, particularly with management, is everybody wants answers right away. So if you're an IR investigator, you're probably just sitting down, setting up your tools, getting into whatever logs, and you have some management guy 10 minutes later coming over and saying, hey, what'd you find? So one of the things that we're going to try to answer with triage is the who, what, and where, and how. It's not going to be all the details, but we're at least going to start collecting machines and tools as we move along and figure out which boxes were affected. We can start making our timelines to answer the who and what and where. And, sometimes we'll get lucky and figure out the initial, how they initially got into the network, and that's the how. With the other questions we want to answer is, did we have lateral movement? And what tools were ran? The other thing that I recommend to everybody is practice with your tool sets that you have available. Get with your management, say, hey, we're going to practice a scenario where we have an APT actor. Let's set up the tools, just run it through a drill, because the first time it happens, you're going to be behind the ball. And having that practice with the tool sets means you're going to be able to respond faster. You won't take down the business because some things you may do may end up shutting down servers. You know, you don't intend to do it, but there was something weird with the tool. We've seen that occasionally with some tools out there. And the other thing is you can figure out your methodology that works best for your company. Now, one of the tools that I'm going to talk about is ECAT. And this isn't really an advertisement. I'm going to talk briefly about what ECAT is, and then I'm going to get into some advanced uses for ECAT. If you guys are really interested in checking out the tool, we do have free demos that you can participate if you want to stop by the booth. So, ECAT is a signature-less endpoint threat detection tool. An agent gets put onto the host machine. It's going to be at the kernel level, so it's able to do deep endpoint visibility and real-time threat alerting. There is no signatures associated with ECAT. It's not an antivirus product. Everything is based on behavior. You can confirm infections real quickly, and we do this by using whitelists. So when you install the product, you're going to create a golden image, whitelist all your known good binaries and things of that nature. And then as you use the product, you can subtract the known good, and what you have is the unknown. It doesn't mean that everything is bad. It's unknown. And so you'll have to take a look and figure out if it's good or bad. Basically how it works is we have an ECAT server, and like I said, there's agents on every single endpoint. The agents are going to talk to the ECAT server to get its new, what you want me to do. Do you want me to do a scan? Do you want me to send you files? Things of that nature. Oh, and here's the list of behavior that I've seen with binaries running on the machine. At no point can the ECAT server directly contact the agent. So it's always agent to server communication. As I said, everything runs on the endpoints. We do support Windows and Mac OS. And basically, we monitor all the activity on the machine. We identify executables, DLLs, drivers, and it's a very low impact to the box itself. The only caveats I'm going to make to that is that if you're in a virtual environment, there's some other things that you have to be aware of as you do scans, is that you have to make sure you're not overrunning your I/O. But we have directions and all that on how to address those issues. The server itself is going to analyze the data, and it's going to flag for anomalies. So basically we have IOCS, basically it's behavior-based alerting methods. And for example, if a said process creates a at job and then runs a shell, you can create an alert for that. It's also going to automatically download any unknown files. And at the ECAT server, from there, you can take a look at the files and determine, if it's good or bad. Some of the techniques it uses, it has disinspection and live memory analysis. So what we mean by that is if you're running Adobe, for example, and you uploaded it, or you opened up a PDF, and that PDF does a buffer overflow of some kind and inserts a DLL or executable into memory, ECAT's going to detect that. It's going to save that malicious code off the disk and upload it to the server. Then, as Adobe is running, one of the things with what it does for detecting anomalies is this going to compare what's on disk versus what's in memory. So what I mean by that is a particular DLL that's, let's say, gets replaced on in memory, or it gets hollowed out, what have you. ECAT's going to take that DLL in memory and compare it to the one on disk. If they don't match, then it's going to say, hey, this is weird, and it's going to raise a red flag. The other thing is it does do behavioral monitoring. So when a user clicks on a malicious email attachment, the attachment drops a piece of malware, and then from there it contacts the C2. ECAT's going to track all that behavior associated with those binaries, and it puts it into a database. And this is one of the things that we use to identify malicious behavior. Now, this is all great if you are currently running ECAT at your business. So if you have all this, you have a centralized point, and it's real easy to spot malware and things of that nature. But in those scenarios where maybe you're new for ECAT, or you have an APT thing that just got notified, what I'm next going to cover is some advanced uses for ECAT. Actually, right after this slide. One other thing is here's a screenshot of the incident IOCs. And what this is it takes the behaviors and data that's been gathered into the ECAT database, and more or less you're doing SQL queries against that to produce other metadata. So with this sort of thing, as I have here on the screen, this particular in the gray box here with the red, that is a remote @job behavior detection. And you can see it's a SQL query. You can write those all day if there's something that you're interested in the IOCs. If you find something with a particular binary and you can produce the behavior techniques and things of that nature, you can throw that into the IOC database. So Windows Triage using ECAT. So from here on out, we're not going to see too much more about ECAT as far as screenshots and things of that nature. What I'm looking at here is doing advanced detection methods using ECAT as a helper tool. So I can't cover everything in the time that I've been allotted. So at most I'm going to cover some quick things, some things that will allow you to detect commodity and APT in your networks and allow you to start looking at other boxes. So some of the first things we're going to take a look at is @jobs, schedule tasks, task schedule logs, and the app cache. I have the listed files and directories there. So one of the things that ECAT does automatically is it parses all the jobs. So when it does a scan, it'll get all the @jobs and all that happy stuff out of the registry and puts it into a database. And using some SQL, in this particular example, I am querying the database directly. I'm not using the ECAT server or the agents. And what this is going to do is bring back a table of all the @jobs that's available in the database that ECAT knows about. So that's an example of the query, and then down below shows how to run it. And this is going to export this into a CVS file. Then what I'm going to do is I'm going to do some frequency analysis on the jobs. This is where practicing with your tools kind of comes in. So when you start taking a look at this big long list of jobs, you're going to be able to determine, hey, this is good, I don't know what this is, and this is bad. So in this particular example, I'm using Linux just to help reduce the number of things I'm going to take a look at. So I'm going to cut out the fields I'm not interested in. and then I'm going to sort it. I'm sorting it based on, for example, alphabetical up there. I have ASUS, AT1, and what have you in an alphabetical sort. And then I want to get a unique counts. This is where my frequency analysis comes in. So when I have 40,000 machines, I can start reducing the known good just based on frequency. You know, because APT is not going to touch all 40,000 machines. They may touch 20 or 30 boxes, maybe 100 at most. And you're going to start seeing odd things when you take a look at it this way. I'm going to sort it one more time. So it's sorting it by number counts. So that way it's a little easier. I want to take a look at the number ones, you know, one of jobs, right at the top. As you can see here, the one where I have a little piece of gold next to, that is something I'm going to key on as something that's odd. The rest of it, you know, looks normal. The network that this particular came from wasn't super huge. So, but you can kind of see, like at the bottom, Adobe Flash Player Updater. I have 4 counts of those APT jobs, or AT jobs, I should say. And that's something I can just rule out because it, you know, looks benign. So once I've figured out what looks odd, or what I know is whitelisted, I can start using grep to start removing the known good to make that list smaller. So that's an example of the known good to just make that list a little smaller, make it a little bit easier to review. And the higher the counts, like I said, the less likely that it's going to be bad. So as identifying AT jobs that are odd, I'm going to then want to request more information about the particular AT jobs. And I'll get to that in just a little bit. I'm going to move on to schedule logs. So within the ECAT, one of the nice features is I can request files and directories. I can do that across every machine that has the ECAT agent. In this particular case, I'm getting the schedule logs because I want to parse those and do the same sort of frequency analysis as I did with the AT jobs. Here we have a screenshot of what it looks like to request files. From there, I'm going to process these jobs into more or less a list that I can start reducing down to do the frequency analysis. I'm using the find command to, for example, because I've downloaded all those schedule jobs, and I need to run it to through this Perl icon. Basically, that's going to take the schedule logs and turn them into ASCII, and then from there I'm grepping out certain lines from those text logs and saving it off to a file. The second step is I'm going to cat that file, and I'm going to remove the schedule LGU. I'm going to sort it, unique it, and then run the same process for frequency analysis. As you can see here at the bottom, I have an odd job that runs run DLL32. Everything else is, you know, like the Google update, the Ask Toolbar job. That is all pretty much normal wherever you go. But hopefully you can start to see how we can start picking out some of the oddness that we're seeing. The next step in the process is once I've identified something that's odd, I can then, I'm going to search all my job files for which one it was contained in. So, for example, that big long line there that's being shown, that is the name of the file that was downloaded from the ECAT box. So every single machine will have something similar. It will be slightly different. This whole thing. So where I pointed there, that's a SHA-256. So I can take that SHA-256, go into the download tab for ECATs, and then figure out which box it was. And then from there, I'm going to start diving into that box and figure out what's going on with that job. App cache is kind of along the same way. I'm going to have ECAT download all the system hives. I'm going to run it through RegRipper. Now, one of the things I did with RegRipper is I made a small modification to the app cache plugin, and it's going to produce the output for the app cache in a CSV format like you see there at the bottom. From there, I'm going to do the same type of frequency analysis as I've been talking about, is looking for low numbers, odd file names, and odd places. So this perflogs csv.exe, that was something we really found, and it was malicious. The same thing for the line below it where it starts with 7, Windows debug csv.exe, was the same file, just in 2 different places, and depending on where the APT actors decided to put that. So as I identify files and things I want to take a look at, I'm going to go and figure out what the host name of the machine is, or do the same sort of thing with the system as I did with the schedule logs, and find that SHA-256 hash, and then search the downloads for which box it was, and then dive deeper into the box. Step 5 there, if you run RegRipper on the system hive, it'll tell you what the host name of the machine is. It's all in that particular hive. Task scheduler logs. This is sort of the same thing, frequency analysis. I'm going to download all these, and then I'm going to process those using one of the 2 tools above it. And the only ones I really care about is job ID 102 and 129. I want to know if there was an accessible job or if there was a created task. So once I've dumped those out into a CSV file, I'm going to set it up for frequency analysis again, and then start combing through that. As you can see here, the arrows that have pointing to the left are just odd names, odd paths, and things of that nature. So these are going to be things I want to take a look at. So then, I can go back. I'm going to search the scheduler logs to identify which file it came from. And then, basically, like I did everything else, I'm going to look at the download tab within ECAT to figure out which machine it came from, and then do a deeper dive. The other thing that's worthwhile doing is downloading the software hives for, like Windows 2008, things of that nature, because the tasks are stored in the registry. It's no longer job files. So there's an example of the reg dump. I made a slight modification to it to show, I'll show you here. So in step 6 here, I have one of the task schedules. And the thing I'm really interested in is the actions. And it comes out as binary with a reg dump. With a slight modification to it, the very bottom line is I have the actual ASCII that it's pointing to. So this is another indication of something I need to take a look at. But what pointed me to this was my search here through the scheduler log. See the task name /info? And then here where it says path is /info. So this is additional step in identifying this badness. Probably what my next steps after this is going to be is to get a copy of MFT, pull it down, and start investigating the box. So what we have so far is a small list of data that looks odd. It's going to be associated with boxes that we're going to want to take a closer look at. Just to further go through this a little bit, each part of the metadata, the @jobs came from the @jobs CSV that I created with the downloading of the SQL table for the @jobs. Well, I have data there from the schedule gu.txt file, and then the app cache. And, if you didn't catch it, each time I find a piece of data, I want to correlate it back to the ECAT box, determine which machine that it came from. And I do this by taking the SHA-256 hash from the file name, put it into the download tab for a search, and then finding out where that came from. And then I'm going to start diving into that box to identify what's the tools, what the exfil was, what have you is going on with that machine. And here's an example of that. So I have the 256 SHA hash at the top. I've identified the file it came from. I can right-click on that line and identify the box. Some of the next steps I'm going to have is I'm going to conduct a full scan of the box boxes that I'm interested in. So I pretty much took it, let's say I have 20,000 machines. I've done this process. I should be able to narrow that down to a small handful, let's say 100 machines or so that need to be taken a look at. All of these steps take hours, not days. So your your longest pole in the tent is downloading that data. So, you make the request for the data to be downloaded, as in the files, given an hour or two. And during that time, you can take a look at the @jobs, like I outlined. By the time you're finished with that, you should have files that you can start reviewing, and you just start queuing that up with scripts and start doing frequency analysis. It all comes very quickly. The other thing with the full scan of the machine is I'm going to take a look at the MFT. There might be some additional data. There might be some deleted files that I'll want to recover and take a look at. The other thing that ECAT does do is it does allow for Yara signatures. And I can create my signatures and use those to start scanning the other boxes as I find malware. Other steps that you can do this frequency analysis. You can apply it to the AM cache or the recent file cache. I don't have time to go over those steps, but the technique should be the same for whatever you're interested in taking a look at. Here's a picture of Yara IOC. So this would be something as I write my Yara IOC rules, or my Yara signatures, and then I redo another scan. I can quickly determine which boxes have a hit, and this may lead to some additional boxes that I haven't got to yet. I thank you for your time. If you guys are interested in some of the code or a copy of the presentation, there's my email address. I'm more than happy to share it out.